Write off this information in the meantime. All right. We're gonna start with doing some questions concerning the derivatives of these functions. Let us see how many of them we can get through. When you think about it, we would have started differentiation about 3 weeks now. So some amount of how we go about differentiating should be familiar to us, right? And so some things that we're working out should not be strange, should not come across as strange. And so once we'll be doing questions, you should be familiar with what it is that we're doing. All right. You guys hearing me clearly? Hello? Are you guys hearing me? Hello? Oh God.
Yes, sir. Hearing you now.
Okay. All right.
Sir, hold on, you gone up, man. Where you gone up? Go down back, sir, please.
So, oh, you just a start right.
Yes, sir.
All right then.
I'm gonna come across because I did sitting there, sir. So that's why I'm happy time.
All right. All right. Let me know when you finish writing, please.
So they ask if them had the rule of the
Yes.
new
Yes.
lesson.
Yes, they are. So if you notice, it says the derivative, which is saying that if you have a function to say y is equal to e to the x, and you're asked to find the derivative, which is differentiating the function with respect to x, you're just going to get back e to the x. So if you have y is equal to any of these functions and you differentiate them, this is what you would get. Or it would be in this form. And we're going to look at questions of how to work out different functions when you're asked to differentiate it of in those forms. All right, let's see what we're working with for the solutions for fun. So we have y is equal to sine x squared plus 3, right? Notice it would be in this form, the ax plus b. So when we differentiate, we can use the chain rule to differentiate it, as well as we can just use the regular differentiation rule. So how we do it is this. So first I'm going to use the chain rule over here. So I'm going to say let u equals to x squared plus 3, right? So we're using a substitute. So that means this is going to be y is equal to sine u, because all of this part is now u. So what we can say is this. We have two things to differentiate. We have u is equal to x squared plus 3, and we have y is equal to sine u. So we can say we can find the derivative of u with respect to x, which is going to give us 2x. And we can find the derivative of y with respect to u, which is when you differentiate sine, you get cos of u. All right. Now, to find the derivative of this function, which is the original function that was given, it is going to be the derivative of y with respect to x, and that's going to be equal to du dx times dy du. So if you notice, if you cancel this du and this du with each other, you're just going to left with dy over dx, which is what we're solving for. Yes? So what you end up with, du dx is 2x, and it's going to be multiplied by cos of u. So it's going to give us 2x cos u. But bear in mind, we know what u is. We had said that u was equal to x squared plus 3. So this is going to be 2x cos of x squared plus 3. So that is what we would get for the derivative of that function. All right. Another way we can do it, which is not using the chain rule. Y is equal to sine of x squared plus 3. So notice what is in bracket is the angle. So notice you're taking the sine of an angle. So the angle here would be x squared plus 3. So what are the steps we are going to take to differentiate it otherwise? Step 1, you're going to differentiate as is. And then step 2, you're going to multiply by the derivative of the angle. So you differentiate as is, then you multiply by the derivative of the angle. All right. So if we have y is equal to sine of x squared plus 3, when you differentiate sine x, we get cos x, right? But it is sine of x squared plus 3. So when I differentiate it, it's going to give me cos of x squared plus 3. And then we're going to multiply by what we would get when we differentiate the bracket. If I differentiate this bracket, I'm just going to get 2x. So my final answer would be 2x times cos of x squared plus 3. So this is another way that you can do it. So notice we would have finished the question in what? 3 lines. So from the question to the answer. So you can choose if you want to use the chain rule by doing the substitution, or you can use this way of doing it. Either way you do it, there's no more marks for one way. So if you do it the first way, chain rule, or the second way, none of the ways give you more marks. All right.
Sir,
Yes.
sir, so
Go
yeah,
ahead.
sir, I'm kind of finding it difficult with the chain rule, sir. You have to use it on the exam, I know.
No, you will determine you will determine which way you want to work it out.
So, so sir, sometimes the question them now go come in a way where you have to use the chain rule, I know. This I said we can use either or.
Either or, because one of the things we not try to do is restrict. There are some questions where you restrict students because you want everybody to have the same answer, and some where you don't. So, like even a question like this now, we're not going not we don't have to specify that you have to use the chain rule, because the chain rule is not the only way to use to solve the question.
So I understand.
Yeah, man. So y is equal to cos 4x squared plus pi. Now, pi is a number, so this would be a constant because the function is written in terms of the variable, which is x. Pi here is a constant because we know pi to be 3.14 or 22/7, so that's a number. All right. So you don't have to be alarmed by it to say, how am I going to differentiate pi? Pi is just a number in the question. So we can again differentiate as is and then multiply by the derivative of the bracket, or we can just use the chain rule. So whichever way you choose to use to do it, it's not going to be a problem. All right. So just for emphasis again, we're going to use a chain rule. So we're going to say let u equal to 4x squared plus pi. So if we change all of this to u, then that means the new equation is going to be y is equal to cos of u, because u was used to replace 4x squared plus pi. So if u is equal to 4x squared plus pi, then the derivative of u with respect to x is going to be equal to 8x, because pi is a number. And if we have y is equal to cos of u, then the derivative of y with respect to u, when you differentiate cos, you get negative sine. So we'll get negative sine u. All right. So differentiating this function, which is the original function with respect to x, the derivative of the function with respect to x is going to be equal to du dx times dy du. So you have to multiply these two things. All right. So du dx is going to be 8x times negative sine u, which would end us giving us negative 8x sine u, and we know what u is, so it's going to be negative 8x sine of 4x squared plus pi. So this is what your final answer would be. So this is using the chain rule. Now, using the other method, just remember differentiate as is, then multiply by the derivative of the angle, or in other words, the derivative of the bracket. So using the other way, y is equal to cos 4x squared plus pi. So dy dx differentiate as is, differentiate cos, you get negative sign, and it's going to be 4x squared plus pi. And then you multiply by the derivative of the bracket. So if I differentiate this bracket, I just get 8x. And then multiply negative 8x sine of 4x squared plus pi. So that's all you would end up with if you use this method to work it out. Whichever method you choose is going to be up to you. You have a question?
Yes, sir. What's the other name of the other method?
Well, it's not, it doesn't have a specific name, it's just differentiating. So there's not a name, so to speak, for it.
Okay, scroll down. So, please.
As you need more than that?
Yes, sir.
So you
The
need
part.
still more?
Say part we say step one differentiate and step two multiply. That this that part they say. Which part did it? See it. Yes, sir. I can tap this one. Alright, sir. Can scroll back up.
The same is true if we have a question like this, question number 3. Say for instance, we have y is equal to sine 4x and 4, y is equal to cos 7x. All right. So using the short way, you differentiate as is, then multiply by the derivative of the angle. So
Yeah.
dy. So differentiate sine, you get cos. So it will cos 4x. Then if you differentiate the angle, if you differentiate 4x, you're just left with 4. So this is going to be 4 cos 4x. So that would be the answer. Same over here. If we differentiate as is, differentiate cos, we get negative sign. So it's negative sine of 7x squared. And then the derivative of the angle is 7x squared. So you would multiply by 14x. So this is going to give you a negative 14x sine of 7x squared. So that is what you would get for the answer for those two questions if you were asked to differentiate them with respect to x. So notice the short way can cut down on the time that you're spending on these type of questions in the exam so that you can move on to other questions. And if you know something giving you a little bit of trouble, at least you can spend time on those questions rather than these that you don't have to be spending the time on. All right, anything I need to clarify about question number 3 and 4?
So man said the one above, sir, the one in black.
Yes.
So I think your times is signed by the four and then the by
No,
signed by.
it's not an expansion. You're not expanding the bracket. It is differentiate as is. Notice the rule never say expand the bracket or multiply or distribute. It says you differentiate as is and then you multiply by the derivative of the bracket. So if I have this, if I have cos and differentiate cos, I get negative sign and I write back what is in the angle. So notice. So I did write it up here, so no. But from when we were doing regular trig function, once you differentiate cos, you get negative sign. You write back what is in the bracket. Then you differentiate what is in the bracket. If I differentiate 4x squared plus pi, I get 8x. So I just multiplied it. So notice the negative 8x sign what is in the bracket. So nothing more than that. So you're not multiplying out the bracket or anything like that.
All right.
Say for instance, you have y is equal to sine of pi over 2 minus 4x, and you have number 6, y is equal to cos 2 pi minus 9x cubed. All right. Try number 5 and number 6. Let me see what you would come up with for your answer, please. And then after this, we're going to look at question with tan, and then we move on to other questions. Yes. Yeah, money, respect. All right. So when you differentiate sine, you get cos. So let's look at the answers for these. So dy dx is going to be equal to cos pi over 2 minus 4x. Now, pi over 2 is just a number because if pi is a number and you divide it by 2, then you're just going to get another number. So when you multiply the derivative of the variable part, which is negative 4x, and you differentiate negative 4x, which is a number times a variable, what would you multiply? What would you get for the answer? Go again? I didn't hear that.
We'll say I get the 4, negative 4.
Negative 4. So we're going to get negative 4 cos of pi over 2 minus 4x. So that would be your answer. dy dx, differentiate cos to get negative sign. So it's going to be negative sine of the angle, which is 2 pi minus 9x cubed, multiplied by what you would get if you differentiate the angle. 2 pi, if pi is a number, then 2 times a number gives you back another number. So that means 2 pi is a number. So what would you multiply by? um Negative 27x squared, right? Because 3 times 9 is going to give you 27, subtract 1. All right, so you get negative 27, and a negative times a negative is going to give you a positive. So you'd end up with positive 27 x squared sine of 2 pi, sorry, sine of 2 pi minus 9x cubed. All right, so that's what you would end up with for your answer for that one. All right, so let's refresh ourselves on the tan business so we can see how to work this out. So we're going to just refresh ourselves on the tan business. Um, if we have y is equal to tan x, that's the same as saying y is equal to sine x over cos x. Now, bear in mind, this would be using the quotient rule where you have the numerator and the denominator. So if u is equal to sine x, then the derivative of u with respect to x is going to be cos x. And if v is equal to cos x, then the derivative of v with respect to x is going to be equal to negative sine x, cross multiply. The derivative with respect to x is going to be v times the derivative of u, which is cos x, times cos x, minus u times the derivative of v, which is sine x, times negative sine x. All divided by v squared, and we know that v is cos x all squared. So this is going to be equal to cos squared x, negative times a negative, positive sine squared x, all divided by cos x, cos squared x. Now, from our trig identities, we know that cos squared x plus sine squared x is going to be equal to 1 over cos squared x. And one of the things that we know from one of the rules that I gave you is that 1 over cos x is equal to sec x. So if we have 1 over cos squared x, then that's going to be equal to sec squared x. So that means when you differentiate with respect to x, tan x is going to be equal to sec squared x, because 1 over cos squared x is the same thing as sec squared x. So the question now becomes, if I differentiate y is equal to tan 2x squared, what would I end up with? Right? So it would be, what would I end up with? Anybody can answer.
What's the question?
If you differentiate tan 2x squared, what would you end up with?
So, x times the tan 2x.
Go again. I think you're I think for me I hear you sound close. Go again with me, yes.
X.
Yeah, break up very bad, you know.
Yeah, you hear me, sir?
Yeah, go on now. You sound
So it'll be 4x, take 2x, and then put the square brackets here.
sound.
X. So you know, hear me?
Yeah, me that hear what you say, but the answer gone off a little bit.
So may I say two 4x sec 2x and then put the tan 2x squared in a bracket or no, sir? That would have been
No,
answer.
no, you gone off a little bit.
Uh,
Anybody else want to try? Well, you could definitely try working it out, you know. Let me show you what I mean when I say you could try working it out. If you're not seeing it. This would be y is equal to sine 2x squared over cos 2x squared. So you have u and you have v. Let me use this color. So u is equal to sine 2x squared. So the derivative of u with respect to x is going to be equal to 4x cos 2x squared. And v is equal to cos 2x squared. So the derivative of v with respect to x is going to be equal to negative 4x sine 2x squared. So when you cross multiply, what you're going to end up with is the derivative of y with respect to x is going to be equal to v times the derivative of u. So it is going to give us 4x cos squared 2x squared minus, well, no, let me backtrack a bit. What I did was work it out here, and I shouldn't work it out already. I'll work it out. Oh yeah, 4x cos 2x squared times cos 2x squared minus sine 2x squared times negative 4x sine 2x squared, all divided by v squared, which is cos 2x squared squared. Alright. So that is what we're going to get right there. All right. So here we go now. When we multiply 4x and cos times cos is going to give us cos squared, and then we get the 2x squared plus negative times the negative. We're going to get the 4x. Sine times sine is sine squared, and then the angle, which is 2x squared, all divided by cos squared 2x squared. All right. So if you want, you could separate the angle so you see where the angle is, and that is what you would get for your answer. All right.
Answer to what, man? The so
No,
example.
no, not the final answer. No. What I'm showing you is that what this is what you would get after you expand up here. So, all right. So now you just have to continue and simplify it down, because remember, we would have already known that if we have y is equal to, oh, sorry, cos squared x plus sine squared x, that's equal to 1. All right. And then all we would have to do is just simplify what it would be if we have, so we can factor out 4x, because 4x is common. All right, let me make a write off right here. So first, and then we finish working it out with the doing the factorization. So you'll show you what you would end up with. All right. So what we're going to end up with is 4x open bracket cos squared 2x squared plus sine squared 2x squared, right? All divided by um cos squared 2x squared. All right. So that's equal to 1, the numerator, but it's multiplied by 4. So we're going to get 4x over cos squared 2x squared. So instead of having 1 over cos squared x, we would now have 4x over cos squared 2x squared. So it is just the same thing as saying as if we had 4x times 1 over cos squared 2x squared. So we'll think x would be what is in bracket here, and 1 over cos squared of x is going to give us, so this is going to give us sec squared of the angle, which is 2x squared, and you're multiplying by 4x. So it's going to equal to 4x sec squared 2x squared. So that's what you would get for your final answer. So one of the easiest way you can think about it, yes? So I wanted to guide you through that first because it is far more easier than this, because we can use the identity that we have here. If we take the derivative with respect to x of tan x, and it is equal to sec squared x, then the derivative of tan of anything right here, so which is the angle, it is just going to be the derivative of the angle multiplied by sec squared x, which means it, just as though if we have the derivative, so I can just show you a few examples of tan 2x squared, it's going to be equal to the derivative of the angle is 4x, so it's going to be 4x times sec squared of the angle, which is 2x squared, right? Which is what we got right here. So say, for instance, we had the derivative of tan of ax plus b. It is going to be the derivative of the angle, which is a, times sec squared of the angle, which is ax plus b. So that's what we would get if you take the derivative, of anything relating to tan. So let me give you another example so you can see what I'm talking about. Say, for instance, we have, that was number what? Number 7. Say, for example, number 8, we have y is equal to tan of 2x plus pi. Tan of 2x plus pi. All we do, we can say, since the derivative with respect to x of tan x is equal to sec squared x, then the derivative with respect to x of tan 2x plus pi is going to be equal to the derivative of the angle is just going to give you 2, and then you multiply it by sec squared of the angle, which is 2x plus pi. All right. So that's what it will work down to all the time. So whatever the angle is, you take the derivative of the angle, and then you multiply it by sec squared of the angle, which is, in our case, 2x plus pi. All right. One of the things that I would caution you about is that if you're in an exam, pay attention to the marks. Sometimes the marks is an indicator to show you that you don't have to do a lot of working. All right. All right, so now we're going to look at the derivative of the ln functions with ln and function with e to the x. Always bear in mind, once I say first derivative, it is the same thing as your gradient function. So if I say to you, find your gradient function, you must know that is your first derivative. If I say to you, um, find the first derivative, you must know that it is your gradient function. All right. So if I give you a equation and say find the gradient, you must not be there looking to say what gradient? What does I mean by gradient? All right. Anybody still writing? Okay, I take that as a no. Say we have y is equal to e to the 4x. Now bear in mind, if you have y is equal to e to the x, and you take the derivative of it with respect to x, you're just going to get back e to the x. But once you have y is equal to e to anything multiplying by the x, or you have an expression there, you have to take the derivative of the exponent. So 1, you're going to differentiate as is. And then 2, you're going to multiply by the derivative of the power slash the exponent slash the index. So you multiply, differentiate as is, then you multiply by the derivative of the exponent. So this, I would go ahead and write it as dy dx is equal to e to the 4x multiplied by the derivative of the exponent. If I differentiate the exponent, I'm just going to get 4. So this is going to be 4e to the 4x. So that's what I would get for my answer. All right. Say for instance, we have y is equal to 3e to the negative 3x. So because we know that when we differentiate, we get back the same thing. So it's going to be the same thing. Multiply by the derivative of the exponent. If I differentiate the exponent, I just get negative 3. So I'm going to end up with negative 3 times 3, negative 9e to the negative 3x. Differentiate as is. So I'm going to get back the same thing and then multiply by the derivative of the exponent. If I differentiate the exponent, what would I get if I differentiate this exponent?
Sir, 2.
2. So I would get 2 times 4, that's 8e to the 2x plus 4. Is there anything I need to clarify for anyone?
No, sir.
So find the gradient when x is equal to 0. Go ahead and see if you can solve that one for me. All right, did we get that answer?
Sir.
Go again.
Sir, yeah, we did get something similar.
Okay. All right, let's look at a few more questions. Um,
Yeah, hold on 1 second.
all right, try these three questions for me, please. All right, we finish working these questions. All right, let's see what we have come up with so far. If we have y is equal to 3e to the 2x squared plus 5x minus 1, then the derivative e to the 2x squared plus 5x minus 1 multiplied by the derivative of the power, which is just going to be 4x plus 5. So your final answer is going to be e 4x plus 5 3 e to the 2x squared plus 5x minus 1. You don't need to expand this bracket. You can just leave it as is. B, we're going to have y is equal to e to the tan 2x. So derivative is going to be e to the tan 2x times the derivative of the power, which is going to be 2 sec squared 2x. So your final answer is going to be 2 sec squared 2x e to the tan 2x. Got those answers so far?
Sure.
B e to the 2 cos x plus sin x. So to differentiate as is, we're going to get back the same thing. 2 cos x plus sin x times the derivative of the power, differentiate cos, you get negative sine. So it's going to be negative 2 sine x, differentiate sine, you get cos x. So your final answer is going to be negative 2 sine x plus cos x times e to the 2 cos x plus sine x. But it says when x is equal to pi over 2, so dy dx when x is equal to pi over 2, we're going to get negative 2 sine of pi over 2 plus the cos of pi over 2 times e to the 2 times cos of pi over 2 plus the sine of pi over 2. Now, cos of pi over 2, that's 0. So this is and sine of pi over 2, that's 1. Because this pi over 2 is the same thing as 90. This is going to be e to the 2 times 1. No, cos is 0. 0 plus the sine of it is going to be 1. So this is going to be negative 2 e to the 1, which means that the gradient is just going to be negative 2e. All right. So that's going to be your gradient, negative 2e. Did we get that answer or anything close to it?
Sir.
Go again.
Something good.
Okay. Somebody else was saying something. All right, let me let you write that off and then we look at some that involves length. All right, let's continue. So bear in mind, if you have y is equal to ln x, then the derivative of y with respect to x is going to be equal to 1 over x, right? And if you have y is equal to the ln of ax plus b, then the derivative with respect to x is going to be equal to a over ax plus b. Find the derivative of y is equal to ln of 3x plus 4. All right, try that one for me. Let me see what you come up with. All right, so we should get that dy dx is going to be equal to 3 over 3x plus 4. Did we get that answer? I didn't hear that.
Oh, yes, sir.
Okay. So dy dx is going to be equal to derivative of sine is cos x. Derivative of cos is negative sine x, all divided by the denominator, which is just sine x plus cos x. If there is any part of the questions you're not sure about, you can just let me know so I can clarify for you. So notice whatever is in the bracket here is the denominator, and then the numerator is the derivative of the bracket. All right, so notice that's what happens. So if you differentiate this bracket, you just get a. And then what is in the bracket is the denominator. All right, try that one, please. Let me see what I end up with. All right, so let me see what to come up with for this one. So dy dx is equal to the derivative of the bracket. If I differentiate this bracket, I'm just going to get 2e to the 2x divided by what is in the bracket, which is e to the 2x plus 4. Did we get that answer? Did you
So
guys
I
get that?
never that we get in as
When you differentiate the bracket, what you get?
so we get e over e to the 2 plus 4.
Oh no, but remember when you differentiate e to the 2x, you have to differentiate it as is, then multiply by the derivative of the power.
So you leave it and multiply. And that's how they say,
So again,
you leave it and multiply it by 2.
remember, so when it is y is equal to e to the ax, then the derivative is going to be a times e to the ax. Yeah?
Get it now, sir.
Okay. So we are to differentiate this function with respect to x. Now, when we look at logs, right, remember the laws of logs, it says um, that if you have the log to base a of m over n, it is the same thing as log to base a of m minus log to base a of n. So the same principle would work for this. We can write it as y is equal to the ln of 2x plus 1 minus the ln of 3x plus 2. So when we take the derivative now, it's going to be, when you differentiate this, it's going to be 2 over 2x plus 1 minus the derivative of this, which is 3 over 3x plus 2. So that is what you would end up with for your answer. The only thing you could do different here is if they had asked you to um, find the actual gradient, which is to substitute in the value of x or a value of x. All right, try these three questions, please. Let me see what you guys come up with for your answers.
Sir. Sir?
Go ahead.
No, sir, I'm gonna ask you if the first one would be 2x squared over 4x plus 2. That I answer.
No, take it again. All right, let's look and see what we come up with for the solutions. If y is equal to the ln of 2x squared plus 2x plus 3, then the derivative of the bracket is going to give us 4x plus 2, all divided by what is in the bracket. So that's what dy dx will give us.
Sir,
Yeah.
so now only the 2x squared with at the up top for the numerator. How come you
Mm.
add 2?
Now remember, notice what we said up here. So that's why we write it down.
Rule?
It says what is at the top is the derivative of the bracket. So whatever is in the bracket, when you differentiate it, that's the numerator. And then what is the bracket? That is the denominator. So you take the derivative of the bracket, and that is your numerator. All right.
Sir, so
So
because the 3, if you find the derivative of the 3 as 0, it
yeah,
would
so
have
when you
been,
find sorry, so when you find the derivative of 2x squared, what you'll get now 4x.
yes, sir. And
And the
then 2.
derivative of 2x and 2.
Yeah, yeah, yes, sir.
So now that's a numerator, man.
Alright.
Yeah.
If you can do so, alright, sir. So,
Yeah.
so anything where you can find the derivative of that would have be numerator.
That's right. So if I differentiate this bracket, I'm going to get 3 sec squared 3x, and then what is in the bracket, which is tan 3x. Now, there's a rule in logs that says if you have log to base a of y to the x, it is equal to x log to base a of y. So that rule is going to apply here because we can say that y is equal to the ln of x squared plus 2. We can take this 2 and write it at the front right here. So we can write it as y is equal to 2, the ln of x squared plus 2. All right. So the derivative of the bracket, so dy and dx, so it's going to be 2 times the derivative of the bracket is 2x, and then whatever is in the bracket, which is x squared plus 2. And then when you multiply by 2, 2 times 2 is going to give us 4x, all divided by x squared plus 2. Okay?
Sir,
Go ahead.
sir, for the exam, sir, the way they would have worded the question, it wouldn't be like this. It would have be like in a worded form, but then get like a real world example, something like that.
So just as how they say, find the derivative of the function this,
Yeah.
or differentiate this function with respect to x, or where it says up here, so where it is, um, find the gradient of the following function, and then it says when give you a value for x. So those are the ways in which the questions will be worded.
All right, sir.
Yeah.
Because I will, with last one, what you do for last year, it did, I said it, so. So that's what I'm
But
saying.
all right, so one of the things that we have to be mindful of, and we have to be careful that when we are learning something,
Yes, sir.
we don't just learn it for a one word or whatever, but you're learning the concept. So notice differentiation. No matter how they word it, once it says that you are to differentiate, there's only one way to differentiate, right? And if they say find the gradient function or find the gradient or anything like that, it's just differentiation. So once you know the concept, remember how mathematics work. They can change the numbers in the question. They can change the wording of the question. But how to work out questions can change because it must follow the concept that it is dealing with, which is either differentiation, integration, whatever the case may be. So that can change. So we have next week, the other week, teaching ends the week of the 17th. Need to check back in. But we're very much on target in terms of where we are and what we have to complete. So we're in a good place. There's some worded problems that we have to solve on trigs, not trigs, on differentiation. Which will see us doing some graphs as well. So I need to show you that. But it's going to be necessarily important that we are at class early because we started class an hour late today because many of persons were not here. And that can definitely impact. As a matter of fact, take for instance, right now in the class, are just two persons in my class. Nobody is in the class face to face. Yeah.
Sure.
And then, yeah.
So every class has same issue teacher nobody now show up. Nobody know come to class. They are school and they not coming in class. So I don't know.
That's
So
a
you just have
problem.
to teach you one learn yourself to be honest. 'Cause you can do so much I know more sometimes. So
That's like, but as I know, even thing when we not talk about even from last semester with evil grades grades going